I'm Dr. Joshua Grenier, and I want to get into and at least have a discussion about 3D printing. I want to talk about it from a dental aspect. We use it a lot, and it does some amazingly good things, but it's got a bad side. There's certain things these materials aren't good for, and there's a really ugly side. Speaking about the health impacts of some of these materials. So let's jump right in. And full disclosure, now I'm a dentist. I 3D print a lot, and I've been doing it for a long time before this whole generation of 3D printers were even available. And in my office, we have almost all of them. We got a Sega, Sprint Ray, Dentifab, which is my go-to right now, Frozen. Really, most of the major names. I do almost every indication, or have done almost every indication, all the way from All-on-X temporaries to single crowns. And I've used a lot of the available resins. I've been able to go to the shows. I know a lot of the people in the industry. So really, the bottom line is, and this is what it boils down to, is follow the instructions for use, follow the safety data sheets. There's instructions primarily from the resin that you're supposed to follow, but also from your manufacturer. So keep that in mind on multiple levels. So before we get into it, let's talk about what's good about 3D printing. Now, what it excels at is creating virtually any shape very easily. It's just the nature of how it works. You don't have to worry about undercuts, at least compared to milling. It's sort of twin, where you don't have to worry about undercuts. You don't have to worry about specific shapes like holes. It can create all of that and create it very easily. The edges don't chip, so you can go much thinner, so you're going to get a lot less material waste. And compared to milling a prosthetic, you're very limited on the types of things you can actually do. So it opens up a whole door. And essentially, from a dental perspective, you can think of it as being able to make any shape of any prosthetic. Now, that also allows you to scale very efficiently because you can make multiple prosthetics, as long as they're small. You can make multiple prosthetics all at the same time. And that's something that you just can't do with a mill because you generally only have one spindle that you can actually deal with. So this is huge. Now, what this means and if there's one thing I had to pick to 3D print, and one good indication, it's for provisionals, temporaries. A lot of dentists, this is what people don't realize, is the hardest part of prosthetics is making a temporary that's really good that the patient can leave with right away. Now, if you're a high-end cosmetic dentist, your 3D printed temp is going to be better than anything that dentist can make themselves by hand. And if you want to do these large cases, they get exponentially more difficult the more temporaries you have to make. So if you're doing 20 temporaries, that's going to be very, very difficult for you. But if you 3D print them, it doesn't get any more difficult. It's going to take you twice as long to do twice as many preps, but the temporaries don't take any longer to actually print. So you can take on a lot more difficult cases. And of course, this definitely makes a huge difference. So there's a lot of other types of applications that just aren't commonly done. And being able to create any type of shape allows you to be a lot more creative in the types of things you can do, but allow you to bring certain things in your office. And right here, this is a surgical guide, which allows you to place an implant in a very specific sort of position. And traditionally, if you're not doing these in your office, you're having a lab do it. And that lab's not a dentist, so they're going to place that implant where they think they should go, and they're probably not qualified to make that decision. And you may help them over the phone a little bit to approve it, but ultimately, the key drive of the process is not you and not a dentist. It's also expensive to do these, and it takes a long time. So it's much better to do this kind of thing in your office where you have control over it. And that's something I would always maintain. And if you're 3D printing these, you can make this prosthetic very quickly, very easily in your office. A lot of very imaginative uses where One key one, if somebody comes in with a existing denture that may be worn, you can duplicate that denture digitally and then turn that into a custom tray. You can relieve it, you can put holes in it, anything you can come up with. So really large variety of options where you can incorporate these types of things into your existing workflows. Finally, we're talking about splints or night guards. Say you have somebody, I've had people that are severely worn and you need to open their bite and move it back to a more favorable, more stable position. Well, you can make your own night guard or splint to do that. Or if you need something quickly, you can just make it in your office. So this is a fantastic use. And really the big thing, and if I had to pick one use for 3D printing, it's the ability to communicate better with your lab. Because you got to remember, your lab is using a digital process. Every lab is already digital. They're way far ahead of where most dentists are. So if you can work with them on a design, one common workflow I use is I'll have them do the design and send me an STL of my final for a cosmetic case. And that way I can 3D print an interim that's the same shape as what they proposed. And when you're doing a tough case, if it's unusual, this can save you a lot of difficulty because the patient knows exactly what they're going to get. So I think it makes you a better dentist because you're communicating with your lab tech from the understanding of how exactly they're doing it. And it makes you much better as a dentist to be working on the same level as your lab tech. Now, 3D printing is changing the world, and we're talking about increasing the access. And you look at what it's done in various other industries, where it allows labs specifically to make more prosthetics a lot cheaper, essentially. So you can provide better care faster and cheaper. And this allows you to do various things. And you look at other industries like the hearing aid industry. Back in 2005, they're one of the first completely changed the industry within 2 years, 2005 to 2007. Virtually every hearing aid is now 3D printed. So it allows you to make various prosthetics a lot cheaper and a lot better. The same with hard night guards. They're a lot easier to make. 3D printed surgical guides a lot easier, and they're becoming the standard in the industry, and it drops the cost and it increases their use. So you can provide better care and a lot faster. And this same type of trend is happening in multiple different industries. Now, the bad. We talked about the good, the incredible things that it's doing and its continued ability to improve the industry. But let's talk about the bad. The reality is, even though they claim that they're ceramic, they are not ceramic, and they will not have ceramic properties. What these really are, 3D printed resins, are a polymer matrix. So they don't have a crystalline state like zirconia or porcelain. They don't fundamentally work like ceramics. And so they will not have these same type of properties as ceramics. They have filler, which increases their wear and makes them harder, increases their aesthetics. And remember, and this is key, filler percentages are done by weight. So they may say, oh, it's 70% filler, 75% filler. But remember, that's by weight. And filler, it weighs a lot more than resin. So what matters is volume. So if the ceramic or the printed resin is mostly resin, then it can be understood as being a mostly resin substance. It's not mostly ceramic. So those volume numbers are impressive, but you got to have the right mental model in your head. So the polymer matrix still dominates the resin, the material's behavior. It's not a ceramic, even if it says 70% ceramic. So a lot of these permanent resins are greater than 50% filler, but that's filler by weight. The actual reality of the material is it's still mostly polymer. So that material has limitations. Really, they're just not as strong. Even newer generations are incrementally better. There's various ways, but you're still not as strong as Emax. You're more like a lucite reinforcer. You're more like an Empress at best. So are these strong enough to actually use? Are they stiff as ceramics? And they're simply not. Now, aesthetics, they look nice, but do they stain over time? And they certainly don't always stain, but they have the potential to stain a lot more than ceramics do. They have a softer finish. They don't maintain a gloss as well as a polished or even a glazed ceramic will. So longevity, yeah, they wear quicker. They don't look as good, and they have various other problems. Like, it's very hard to clean cement from around them because they are made of resin and you're using a resin cement. So that creates problems for you. Now, bonding. Now, this is something that you'll find, and people that do a lot of these will tend to agree. These composite, they're made of composite, so in theory, they would bond very well. But the reality is a little bit different. Because they're slightly flexible, that bond is constantly being challenged. Sort of like if you have two pieces of glass with water in between them, very hard to pry them apart. But if you have two pieces of paper that are wet, you just peel them apart. It's the same thing with resin. Even though it's incredibly bonded immediately in the short term, after it flexes, that bond starts to break down. And they've seen this trend throughout the industry for a long time. So they don't hold up. And there's various ways to accommodate this. And one I might add is, we used to use, we didn't used to have bonding. So we used to get metal restorations to stick to teeth with terrible bonding agents based in the 80s. And we're talking about fundamentals of fixed prosthodontics. So you can add various grooves and shapes and stuff like that to make them stick better. But you have to go old school on these. And I would urge anyone that's doing 3D printed restorations and trying to do them as tempers, if you're doing inlays, onlays, to revisit your old school way. These restorations, because they don't undermill and undermill, fit in these shapes very, very well. So revisit that. Add your grooves, your attention. There's a real science to it. And we need to start prepping like that. If we prep like ceramic and expect bonding to save us, it's not going to work. Now, there's lessons from the industry. 3M, which they have some of the best polymer scientists really anywhere in the world. And I think they still lead, and they still lead the dental industry. Filtech, their bonding agents, they know what they're doing. And they created lava, which is a resin nanoceramic block. And it's stronger than anything that has come out on the 3D printed side because it was made in the lab. And then they would make it and they would mill it. Basically, Filtech on the stick really was an idealized version of what you can do with the types of polymers available to us today. And it was stronger, it was better looking than anything out there. But it didn't work. And it didn't work because it failed more often. It was a little bit flexible and it debonded. And it didn't debond that much. It would only be a few times more. Can you go?
I just wanted to turn off the fireplace.
Okay, I'll turn it off.
So you get hot.
Okay, sorry. I'll turn it off. So anyway, it was what we're doing here is these incredible thing is so it released this block failed a lot. And the problem with it failing is, again, it was the same thing. It was flexible, and there's also issues with the bonding strength as well. But the failure rate was only around 5%. It really was mostly successful, but it had more failures. Zirconia is incredibly reliable. It will debond from time to time, but very rarely because it's so stiff. Now, when you compare that to 3D printed resins, they're even a lot less stiff than even this block. So you're going to see a failure rate that's even higher. It's going to be more than 5%. I guarantee when you see these, when it comes out, it's going to be 20%, 30%, maybe even more depending on how you do it. So if you're prepping these like zirconia or whatever, it's going to not work out well. So, and there are other issues too where you can't get the same type of surface polish that you can get from a ceramic. So they're just softer. So, and they do scratch. In my experience, they don't really get stained quite as quickly, but in some instances, especially for denture teeth, turmeric, whatever it is, they can pick up stain very, very quickly if you're not incredibly careful. So by and large, the average resin isn't that good. You have to be really, really careful there. So really, the verdict on definitive restorations, I would definitely cool expectations. I think there are some indications for inlays and onlays, maybe some direct veneers. If you're bonding directly to enamel, you can get away with it, but you are playing with fire and you can very easily set yourself back. So again, I think if you have low occlusal stress, if you're not really using them under high occlusal load, especially for long, but really you got to understand they're going to debond more, they're going to wear more, they're not going to be quite as aesthetic, and you can, depending on what the patient does, they can stain their teeth more. And I'll admit, in all truth, I've had some patients, I've done some direct veneers on smokers. And what happens is they pick up a stain and then it actually makes them match really well because all the teeth are stained. So that's not always an issue. It's not always that simple. But you got to understand, it is, generally speaking, inferior restoration. Now, let's get a little bit more into the ugly health and safety standards. And this is something that I think nobody really talks about, but is incredibly important. The bottom line is these resins contain a lot of things that are incredibly bad for you. Now, they have a whole cocktail. What they are is they've got a whole lot of monomers. They have oligomers, which are sort of like chains or larger pieces of monomers. And then they have photoinitiators, which are highly reactive substances that when light shines on them, they catalyze this reaction. So the reality is, when they're uncured, these will interrupt and be highly reactive. So they can create a very unpredictable variety of chemical effects on living tissue or on anything they touch. So they're dangerous. They're flagged. I've seen people develop allergies to these, skin allergies that are quite severe, very quickly. It's presumable that they could also develop respiratory issues with these, although I haven't seen that. It makes a lot of sense. And I believe likely it is a result. So these resins, everyone are talking about, it's just an irritant. But it's more than that. It actually, some of these chemicals, TPO in particular, a very common one is, and it causes reproductive toxicity. At least it's been shown to in animal models. And if you look way, way back, we were talking about, they're sort of estrogen mimickers, which can have very detrimental effects down the road. So these are very much substances of concern, and there are a lot of them in various resins, including sprint rays, and probably many others. So when you look at the risks of it, again, TPO is labeled suspected of damaging fertility, allergies, and it causes, and it may have long-term risks as well. So, this is a big deal, and this isn't the only one of concern. There's many other types of chemicals that are in these things. And remember, and this is important to note, is that in the U.S., now, they are much less stringent. So in Europe, a lot of the resins out of Europe are actually very strict. So substances that are of concern are, often not allowed. And I've been to trade shows where they talk about the European resin manufacturers feel like they're being held back. And part of that, and that's maybe one of the reasons why you don't see many permanent restorations out of Europe, because they're not allowed to use some of the things that American resin are able to use. Some of the stuff that's in Onyx and all these other things that are probably really, really bad for you or of high concern. So that's something to bear in mind when you handle these. So the dust, obviously, it is quite bad. There are certainly, they smell, especially if you're leaving them on. The alcohol itself dissolves, so it dissolves some of it, but then the alcohol itself dissolves. So then you have it continually released. So, and then you look at them, there's, some leading people that recommend hand finishing these. So, with a burr. And then you also have a little bit of extra resin on these that needs to be removed. And how are you going to do that? Where your support used to be? Well, then you have to grind down this uncured resin, which means you're going to be breathing in all of this stuff. And presumably, based on what I just said, that might be really, really bad for you or whoever does it. And, most people that have these are not putting them in the type of ventilation that they probably should be done. It's really, these things are as bad, as you might expect, as everything I've said, but they buy a printer and then they just put it in a room and they don't really, and then they leave exposed resin out all the time, and that might be a really bad thing. Now, you can't really use water. You can try to use water, but you're generally going to want to do this in the uncured state. And that means you're going to end up inhaling some of this. So it's difficult. Now, if you look online, when you're talking about using these, if you soak them the way they're supposed to be soaked in isopropyl alcohol, it's going to dissolve these and they're going to get a frosted appearance. So these resin companies are actually recommending to skip that and just manually finish and just sort of wipe it off. Now, if you do that, which you have to do permanent restorations, or it's going to be frosted, it's going to look terrible, that leads to problems. So again, you can try to do something creative on your own. You can try to add some type of substance to the outside, but you're still going to run into that problem. So, and yes, before post-curing, these uncured do have TPO initiated levels that are above toxicological safety limits. So how you finish these does make them safe, and you can, and they do, even with there is some residual TPO in these, and there's other leachable chemicals as well. So it's at low levels if done properly. Now, there is a training factor, and there's actually studies that, it will kill. It's still dangerous to aquatic life if dumped down the sink, and there's a lot of these things. So again, you really got to give it the respect it deserves. You should be using gloves. Avoid contact with skin because you will develop an allergy to this. Train your team. Your team will develop an allergy to these things. And, remember, you can have an issue. So don't get lax. Give this stuff the respect it deserves. And you can see, not just me, but other people have this issue here. Now, waste disposal, most folks aren't necessarily putting these in hazardous waste, but they definitely are. You can't put them down the sink. And again, ideally you would want to cure leftover resin, make sure it's solid, but you're going to do that every time. And liquid resin or solvent should go through hazardous waste. They're not easy to recycle or deal with. And remember, these are or have been shown to be substance. There's components that are toxic to aquatic life. They will cause birth defects in zebrafish embryos is what they tested. But it gives you an idea that these things really aren't that good. So how do you make it? Here's a practical guide. Well, you really need to have a set space, proper ventilation. You don't want sunlight coming on it for one, but you need to keep it away from food, drink, wash your hands. Don't get your hands dirty in the first place. Keep food away from it. Always use food. Do not let the stuff get on your hands if you can possibly avoid it. And remember, when you're learning, try to learn one resin. Try not to change resins. And practically speaking, changing resins within a printer is very difficult. So learn one resin, stick to one, stick with some basic indications, especially for temporaries. Deal with it properly. And remember, don't get this stuff on your skin. Try not to inhale it. And remember, fundamentally what these things are is, they're methacrylate resins. They're basically composite. They're very similar to flowable composite. They have a lot of the same components where you have these monomers that may have branched chains on them. They may even have sort of functional monomers, which can have glass on them on top of. They have larger pieces of monomers that all come together. And there's a large amount of them. And they all have different names, UDMA, PEGMA. A lot of BIS-GMA is almost universal, ubiquitous in dental composites. And they also have those photoinitiators, which I already discussed, like TPO, and there's many others. They have pigments and dyes. They have an assortment of filler molecules, will give them different strength. And now, really, it's sort of like a cookbook. There's a recipe. But you can only make them so strong because you're just dealing with various types of resins. So you're somewhat capped with what you can actually do. Now, 3D printers, this is actually a little inaccurate. Most composites use a slightly different wavelength, looking at 450. Basic 3D printers are more in the 405. So it's a slightly shorter wavelength. And these are like Frozens. These are more the hobbyist ones. But a lot of the higher end printers or more printers are 385, which is an even shorter wavelength. Doesn't actually penetrate as far, but you can get a much more accurate print. So TPO, again, very common. These absorb light and react to free radicals. And that's what happens. And these radicals are strong enough to break up carbon-carbon double bonds, which is difficult to do. And once this is bonding, it makes them reactive, and then they form further chains. And it's almost like a spaghetti where these chains branch off and form these highly cross-linked structures. And that's what gives it its polymer strength. Now, really, when you look at what this has done, it's changed a lot of things in the industry where all of a sudden, one of the limiting factors is designing these things. Especially if you're a dentist, certain shapes, the ability to design these things from a CAD perspective is increasing, and there's a large amount of AI that's starting to be rolled out that can design these prosthetics for people, or at least propose designs. It's already very good at crowns. It's getting into hard night guards. And it's getting into smile design. It will eventually be able to do things like dentures. But we are getting further and further away from just carving on wax. And the result is, the other thing is when people start doing permanent crowns in office, right now they're not treated like dental labs. But it may get to the point where, you are held to the same standard as a dental lab might be if you're creating a lot of them. And that's something that could be of concern. Right now it's not really enforced, but in the future it may be. Even though, it has some huge strength, it reduces wait times, and it really allows dentists to communicate on the same level as their prosthetics. Now, 3D printing, and it really does, just to wrap it all up or begin to wrap it all up, 3D printing has the potential to improve patient outcomes. So you can make devices a lot faster and a lot lower cost that are specific shapes. So if you're doing something, especially a provisional, it's absolutely perfect. And there's a lot of other fields, clear aligners. It probably is a matter of time before something comes along that will allow you to 3D print aligners that are quite good. Or you can at least 3D print the model that your own clear aligner goes on. So, eventually, especially as designs improve, you'll be able to do more and more things. Partial dentures are already getting quite good, but the barrier is design. As that barrier for design starts to drop, it'll be easier and easier to 3D print, these various things. Now, remember, the hearing aid industry is an example where, I can't imagine what it would be like if you dragged your feet, but within 2 years, 500 days, it completely revolutionized the whole industry. And it's not quite doing it. It's been around for a lot more than 500 days in dental, but you got to start to realize how quickly, when technology reaches a certain threshold, design reaches a certain threshold, the resins maybe get a little bit better, or they completely change. They come out with a new type of resin, like 3D printed zirconia. It can absolutely change. The entire industry can go from here to here in a relatively short amount of time. So it's important to pay attention to what's going on. So future directions, again, we just talked about this, improved materials. I'm not convinced 3D printed resins are going to get that much further than they're at right now. They may improve, but fundamentally the chemistry, I use a lot of resins every day, most dentists do, and if 3M can't figure out how to get them past a certain point, if Filtech is the best 3M can do, I don't think we're going to do a whole lot better. It's just part of the nature of the materials that you use. You can change the result, but you're not going to get a radically different behavior from a polymerized resin. Now, there are people that are 3D printing already now. There's Ultra Grenier out of Boston Microfabrication, where you can 3D print a zirconia. You then have to sinter that zirconia, but that's huge. And they're already using this technology to do thin veneers. And, there are some units out there that can automatically do absolutely everything of the step, and it just spits out your final. Now, remember, these can, as you scale up, printers, they're getting larger. You can now 3D print an entire denture in one piece, and it can do different colors as well. So there's a variety of other printers out there now. There's a lot of resins that are on the market that are coming down, and it just is a matter of cost and technology and what people actually use. So things are maturing rapidly. So the conclusion is, again, the good is phenomenal. The good is going to revolutionize the industry. And as soon as something comes along, and it already has, it's going to absolutely take over and change the industry, just like it did with the hearing aid industry. It's doing with the rocketry industry now, where certain components are much better to be 3D printed. The bad is, you got to remember, these materials right now are limited. You're limited by the material that you can actually use. And it's not appropriate to apply them to absolutely everything. Now, the ugly is that some of these materials do have serious health consequences. You're putting them in people's mouths. You're also handling them on a daily basis. And it's important to be aware of what's actually in these. So remember, I would recommend focusing on things that are easy. Interims, number one, first and foremost. It's the most useful thing you can use it for. You can use it for guides. You can use it for splints as well. Focus on that if you want to do interim dentures, interim partial dentures, flippers, all really nice things. But remember, master one resin protocol and then keep after it. And respect what you're dealing with. Keep working at it. Keep discussing it. And remember, this industry is not stuck. It's going to move rapidly forward. So you got to take CE and keep up. So anyway, this concludes my presentation. Thank you. So I'm going to probably do more of these. I hope I'm going to record this. Probably nobody watched, but I'm going to record this And then hopefully get in more of a routine of doing these more sort of every day, 6 a.m. I'll do a quick little